Hello, hope you're doing well. Hope quiz number one went okay. I'm going to grade it as soon as I can and get it back to you. Before you watch this video, hopefully you can complete quiz number one because we're on 2.3 by now, and 2.3 is measures of central tendency. All that means is find the center, okay? But in um, in statistics, one of the things we want to do is find the center. Also, find the shape, find any unusual points, find the spread of data. So the title is of 2.3 is measures of central tendency, but within the section, you're asked to find the spread of data. You're asked to find the shape of the data set. So you're getting a bunch of numbers. And I have two data sets right here. Okay, just examples of an odd data set and an even data set. If you have two different data sets, tell me the shape of that data, tell me the center, are there any unusual points, and the spread. Okay, that's describing data. So we're going to do all those things um, throughout chapter 2. Okay, so spread is more of 2.4. Finding the center, we're going to do now in 2.3. Unusual points, discuss 2.3, and the shape 2.3. Okay, so spread will really get in depth in 2.4 with standard deviation. So the first definition that you see, measures of central tendency, mean, median, and mode. First of all, the mode is not talked about hardly at all in our textbook. The mode comes up the most. And in a lot of data sets, the mode whenever comes up the most. There is no mode in this case, or all numbers are the same. So the mode is all numbers. But we would say there's no mode unless there's a repeat. Like if you saw 8 up there twice, then you would say the mode is 8. So the mode, not really that important. That doesn't really measure the center of your data set. What measures the center of the data set is the mean and the median. So that's going to be a major focus. The median will also come up in 2.5. So right now we're going to talk about the mean. And the first definition you see is population mean, sample mean. Basically, we're finding the average, and you may have found the average before, or you probably have already done this, find the mean of this data set. But there's new language here. There's some variables that are might be a little confusing. So again, finding the center of the data set, we're going to find the mean and the median. The mean is symboled as X bar. The median is symboled as M for median, or MED. You'll see MED also for median. So the mean we can find as X bar, as mentioned. That's called a sample mean. Mu is called a population mean. So we have sample data, we have population data. And there's two means here. Rarely do we use population data. Both formulas pretty much tell us the same thing, but typically we're going to rely on the sample formula, which is sum of X divided by N. So this is new language here. This is sum. All that means is X1 plus X2 plus X3 and so on. Find each X value. Well, what's X1 in my first data set? I'm going to find the mean. 5 plus 7 plus 8 plus 10 plus 20. Again, you probably have already done this in your head. All divided by the sample size, which is N. N is always sample size. N just counts how many numbers there are. There are 5 numbers, so I'm going to divide it by 5. So I'm going to find the mean. Add those together, 15, 20, 30, 40, 50. The mean is 10. Use the new formula to find the mean. Pretty cool. You may have done it already in the past, but now we're talking about population parameters and sample statistics. So we need to distinguish between those two values. Mu will come up a lot more when we move on to chapter 4 and 5. But right now we're talking about usually sample data. And whenever I ask you to find the mean, usually I refer to the sample mean. For example, on quiz number 2, you're gonna have to do this. You're gonna have to say that statistics sucks. Okay. I hope you're laughing by now. Statistics sucks. Yeah, it's a joke. So we're gonna do all these things. So that's the mean. The median, the other measure of center, is the middle number. And this is why I have two data sets up here. The middle number, pretty easy to find. Median is 8. So this is the mean. This is a different data set. And the middle number, I have 8 and 10. So the median is halfway between those two numbers. The median is 9. I didn't even write down what the median was up here. The median, I circled it. The median is 8. Oh, what's the mean for this data set? Let's add them up. 15, 20, 30, 40, 50, 100. And there's 1, 2, 3, 4, 5, 6. And gosh, I got to get my calculator out here. 100. It's not my calculator. 100 divided 6. 16.67. We're going to have a lot of rounding rules in this class. Rounding, make sure that you get as many decimals as you can to make it appropriate. 16.67, I probably wouldn't say that's, oh, the mean is 16. Usually we go out to the nearest hundredth of a decimal place. But there's other cases where we'll round up to the nearest whole number, things like that. So that'll come around later on. All right. So I looked at the data and I found the center. I could say the center. Oh, in the second data set, the median is higher than the mean. I'm sorry, the median in the second data set, 9, is far greater than 8. But look at the mean. The mean is much, much bigger. 16.67 is much bigger than 10. The mean is far greater for the second data set than the first data set. And notice this number 50 over here. This number 50 is a really big number compared to the rest of the numbers. That's be unusual. And the name for any unusual points would be considered an outlier. We have in chapter 2, section 5, a method of calculating outliers. But for right now, we just call it an outlier or possible outlier since we haven't calculated it. So we can find that outlier, that value, as an unusual point. Up here, I would not say 20 is an outlier. It could be, but it's not that far much greater than the median, which is 8. Not much of a difference there between those two numbers. Next would be the shape of the distribution. So I'm going to find the shape. The shape, we have a couple ways to do this. We could say in the shape that is symmetric, your data set is symmetric. There's symmetry. There's some low numbers. There's some high numbers, but most of the numbers are in the middle. So when you go to page 73, I could draw a whole bunch of data sets. But for the shape of the distribution, really excellent graphical displays. These are all called histograms. We have several different distributions. We have symmetric distributions. We have uniform distributions. And we have, these are the most common ones. There's others. And there's skewed distributions. Got skewered. by the statistics today. Okay. Skewed. We could have skewness that goes left, and we have skewness that can go right. So again, according to page 73, we look at the first data set. When the mean and median are close to each other or equal, that's a symmetric data set. So here the mean and the median were closer to each other. The mean was a little bit bigger than the median, probably a little bit skewed to the right data set. Your skewness is usually towards your mean or outliers. Skewness is towards the outliers. But the first symmetric distribution graph on page 73, again, I'm referring to the 8th edition of the textbook. Symmetric distribution. Skewed left, you're usually skewed towards lower outliers. Skewed right, you skewed towards higher outliers. So this one up here, this 50 is pulls the mean to the right of the data set. So that tells me that this data set would be skewed to the right. So you could be skewed left or skewed right. Typically, I'm going to draw a curve here. This is called a density curve. And this should look familiar to some of you. Some people call it a bell curve, but it's a density curve. And these two things right over here, we're going to call them the tails, like an animal tail. Okay, so the tails, this has two tails. Well, skewed distribution, this is symmetric, or we call it normal, but there would be symmetry here. So in 2.1, we learned to make histograms. And from the histogram, we can translate it into sort of a bell curve. So we have symmetric data, but the actual name would be normal. If the data has a tail that goes to the right, we're skewed to the right. I don't really like the graph at the bottom right of page 73. It doesn't really show very much skewness. Some people might say, oh, that's kind of symmetric, but we use the word somewhat. Data is somewhat skewed to the right in that data set. And the opposite is true. If we have data that has the tail to the left, then we would say the data here is skewed to the left. So the third to last data set would be skewed left. So that describes your distribution. So in this data set, I have a small set of numbers. The example of ages from 2.1, ages of students in college. That would be a skewed right distribution. Most students, most of the data is, most of the students are 18 to 23 years old. Okay, that's the ages of a lot of college students. Okay, some students are 25, there's 30. We had a 40-year-old student. Okay, and that's not unusual. So if you're 40 years old, don't worry. I've had a lot of students in their 40s and 50s, but not a lot. Okay, in one year. Okay, so that would be skewed right distribution. Skewed towards the outlier. The outlier would be the upper age. So if I'm using this data set right here, or this graph, this would represent 18 years old down here. And we got, these are ages of college students, 50 to 60 years old students. We don't have very many in this area. Skewed left distribution would be something like age of your college professors. So some students are young, but most are going to be 50 to probably 60 years old college professors, maybe even 50 to 70 years old. College professors, they don't seem to retire very often or very quick. That's shape of distributions. And I kind of skipped a couple things there because they talk about in our textbook finding a distribution that has an outlier, finding a distribution that has two modes. That's called bimodal. But there's two other calculations that we can do. So I'm going to have to start a new page here, and we're going to talk about finding the mean of a weighted distribution. So weighted distribution, let's go weighted mean. So you can find the mean of a weighted mean or a mean of a frequency distribution. So I'm going to have to use my pen here. So a weighted mean, a good example of a weighted mean would be if you're going to calculate your grade in a class. So say there's 50% of your grade is based on the test, 25% of your grade is homework, 25% of your grade is quiz. So you can find a weighted mean for your grade in the class. Given the number of points that you've earned and the weight, you could figure out your grade. So let's just say you have an 80% on your test average. So 80% test average. So this is test. Quiz, you do better on quizzes. You got an 89%. And homework. Everyone seems to do really well on homework, regardless if you know what you're doing or not. Let's just say homework got a 95%. Okay. And I have students come up to me and they go, hey, I got a 95% on all my homework. I did all my homework. What's the deal? How come I have a B in the class? Well, there's weight. Okay. 80% of your grade was on the test. That's your X value. And we use X a lot in statistics. Your weight was 50% of your grade. Quizzes were 25% of your grade. So you can see, I don't have the numbers. I don't have the data in this situation. How do we find the weighted mean? Well, we're going to use a new formula. Page 71. Sum X times W divided by W divided by the weight. Yes, I should put all underneath. There we go. So again, that means sum. I'm going to multiply first, though. I'm going to multiply X and W together and divide by the sum of the weight. I guess I left that off. So I'm going to multiply X times W, but I wrote the numbers down as percentages. We can associate that with decimals. So I'm going to write it as a decimal. So I'm going to do X times W. Might as well make a table here. X times W. So I'm going to do 80% times 50%. How many grade points did you earn towards the test? So that's 40% of your grade goes towards, or it comes from the test, 0.4. So notice, I mean, if you're going to do this as decimals, I did 0.8 times 0.5. That would be the same thing. We got to be able to translate from decimals to percents pretty swiftly. I'm just trying to erase the percentage sign and it's erasing my other stuff. Bring it back here. I could have just did the undo, but I'd be going in circles. All right. 89% of your grade was on the test. So I'm doing 0.89 times 0.25 on my calculator. 0.2225. I don't need to carry out all the decimals. Although I did have a student one year use 8 decimals for every single problem. He was just so worried he was going to get a problem wrong. He was like, this is my 3rd time taking the class. I'm not failing again. So he wrote every problem out 3 decimal places. 0.2375. I'm just going to round that 0.24 because I'm writing this as a percentage. So I want to know what's the grade in the class. Well, I'm going to do the sum of X times W. I'm going to add all these up. Here's XWs. All these are XWs. We do the sum. Again, it's new notation. Just keep an open mind that all we're doing is multiplying these two numbers together and then adding them all up. Let's add them up. 40 plus 22, 62. Plus 24 is 86.86. Well, I got to divide by the sum of W. What's the sum of W? That's 1. Sum of W is 1. That carries all your weight. The weight of your class is based on those numbers. You got 86% in the class. There's an example. Example 7 talks about finding a weighted mean. Final grade, you got your grades. Okay, I like this one as well. So if you have, it's a little bit different example in the 6th edition, but here in the 8th edition, you got your grades and you got your units. So if you ever wondered what your GPA was, you think they're calculating it wrong, find your grade. So let's do another example of weighted mean. So I'm going to do it down here. Weighted mean. You're taking statistics, and we just found that you got an 86% in statistics. That's a B. How many units is statistics? That's 4. And everybody seems to need chemistry and statistics to transfer. That's all I need to do is pass this class, and I'm going to transfer. Heard it many times. Chemistry. I think I got to see chemistry, no joke. When I was a student in college, I worked really hard in chemistry. I think I ended up with C. I can't remember. A long time ago. And then you got a 3-unit class. Let's do what's a good. I wish I had people to talk to right now, but art history. Usually art. Can't remember. It's art 2, art history, 2 or 3 units. I like art and I like art history. I got an A in art. What's the GPA? Okay, that's a weighted mean. Here's the weight. Your units are the weight. Your units tell you how much you have. Because if you just look at A in art, B in stats, C in chemistry, you're like, oh, I got a B average, 3.0. But look at the weight. The weight is going to distinguish between a 3.0 and if you're below a 3.0 or above. So without doing any math right now, I'm pretty sure this is going to be below 3.0 because the most heavily weighted class has the lowest grade. The lowest weighted class has the highest grade. So each of these letter grades is a number. B's are worth 3 points. A's are worth 4 points. C's are worth 2 points. So I'm going to find my X value. Okay, what represents a B? Again, that's 3, 2, 4. X times W. Let's find X times W. I'm going to multiply 3 times 4. Okay. Getting crazy here with the math. 10, 12. I realize not too many people are really good at math. That's fine. If you don't know what those numbers are, use your calculator. What's 3 times 4? 12 plus 10 plus 12. That's 34. So the sum of X times W is 34. Let's use that formula. The numerator, the top, is 34. The sum of X times W. The weight, the sum of the weights, here's the weights. We're going to add all those numbers together. How many units are we taking? We're taking 12 units. So in some cases, they call this grade points. 34 are my grade points. 12 are my units. So that's where the word grade point average comes from. I average, just like in a mean, my grade points. 34 divided by 12. 2.83. And there it is. your GPA. So a couple of examples of weighted means. Again, example number 7 is very, very similar to that, finding a weighted mean. The next mean type that we'll see is called a mean of a frequency distribution. What is a frequency distribution? That's what we spent all that time on in 2.1, creating your frequency, finding the median, finding the relative frequency, finding the cumulative relative frequencies. That's called a frequency distribution with classes and all those things, creating a histogram. We have a frequency distribution. We don't have data again. There's no data. So what do I got to do in a frequency distribution? I need to use a formula. So the frequency distribution, they use the same symbol, X bar, sum of X times F divided by N. Slightly different than what we have over here. N is your sample size. Again, like we showed, or I showed with the mean. They said the sum of the frequencies is N on page 72. So a little bit different when you have frequencies. The same thing. So in our data set for ages, we had 25 people. N is 25. They're just telling you that the sum of the frequencies is N. If you add up, there were 5 people that were 18 to 21 years old. There were 7 people that were 19 to 21 years old. Okay, so we have all those frequencies. We add them all up. That's the sum of F. Okay. All it says to do is take the lower limit plus the upper limit and divide by 2 to find the X value. Find the frequency for that distribution. That's what's given. That's the F. So in a nice example of this, the class midpoint is there. The frequency, the class midpoint is X. So if you do the math, you're going to do, I'm just going to refer to the example on page 72. I'll write it out in case you don't have the book in front of you and you're watching this at work or something like that. I praise you if you're watching at work. So the midpoint is X. And the frequency is F. We're going to find the midpoint. The midpoint was 172.5. Frequency was 3. There were 3 in this frequency distribution. And then the next one was 208.5. Sorry, 208.5. I don't like saying O. O is not a number. 208. That's a 0. Okay. Just getting that out of the way. Trying to entertain you if I can. I know it's boring watching all these videos. 244.5. Frequency is 5. 280.5. Frequency is 6. And 316.5. Frequency is 7. 352.5. Frequency is 4. 388.5. Frequency is 3. So the question is, what's the mean? Okay, again, I don't have data. So I'm going to multiply X times F. Here's X, which is the midpoint. Multiply by the frequency. How do you find the midpoints? Okay, you take the lower limit and upper limit and divide by 2. Did that in frequency distributions, just reviewing it. If the first frequency is 18 years old and the next one is 22 years old, the midpoint would be 20. You add them together and divide by 2 or just find the halfway point. So again, we're going to multiply x times f. Those are going to be big numbers. X times f. I'm going to find all these numbers. So 172.5 times 3, 208.5 times 2, 244.5 times 5. Well, here it is. It said n is the sum of f. The sum of f is your sample size. So I'm going to add all those numbers together. I got 30. N is 30. So once I multiply all these together and add them up, the sum of x times f, 8631. So now I'm going to calculate what's 8631 divided by 30. That is your mean. So I'm thinking the mean, most numbers were right in the middle, just looking at these numbers, probably going to be between 280 and 316, right in that area. Does that make sense? That your average should be right in here. So the average actually, when you do the math, 287.7. And that's a mean of a frequency distribution. Let me double check to make sure I covered all the material you're going to need in 2.3 and looks good to me. Thank you. Hope you enjoyed. Have a good one.